Hello students, let us discuss molecular mass. As we already discussed that when the atoms combines to form molecule, that means when the mass of the atoms is made sum, they give rise to the mass of molecule. So how we define the molecular mass? The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. It is therefore the relative mass of a molecule is expressed in atomic mass unit. As we have already discussed, the mass of the atom is taken as a relative mass, that is in the term of atomic mass unit. So when we make the sum of atomic mass of all the atoms present in a molecule, it gives rise to its molecular mass. So, in order to find out the molecular mass, first of all we have to learn the atomic masses of some element, which are the quite important elements which is given in the table. Once you have to learn this atomic mass, then only we can find out the molecular mass. So, let us discuss the how to calculate molecular mass. Let us take the example of water. As we know that in the water molecule there is hydrogen atom. The atomic mass of hydrogen, when you look it into the table, the atomic mass of hydrogen is 1U, that is a unified mass. Since in the water molecule there are two hydrogen atoms, therefore we have to multiply it with 2, that gives rise to 2U. So the mass of hydrogen in the water molecule is 2U. But there is oxygen atom also. What is the mass of oxygen atom? That is atomic mass. Look it into the table and tell me. That is 16. Since in the water molecule there is only single oxygen atom, therefore we have to multiply it with 1. So it gives rise to 16 into 1 equal to 16U. So the mass of hydrogen in the water molecule is 2U and the mass of oxygen in the water molecule is 16U. So what will be the total mass? That is equal to, when we make the sum, we'll be getting that is equal to 18U. That means 18U is the molecular mass for water. So from this it is clear what is molecular mass. Molecular mass is the sum of the atomic masses of all the atoms present in that molecule. That means you have to take the atomic mass of hydrogen plus atomic mass of this hydrogen plus atomic mass of oxygen, give rise to the molecular mass for water. So it is very simple to find out the molecular mass once you have learned the atomic masses. So let us once again define molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of a substance. That is important. It is the sum of the atomic mass of all the atoms present in that molecule. That means you have to consider each and every atom in that molecule. Then the sum of its atomic masses will give rise to the molecular masses. And here also we are taking a relative mass of a molecule, just like we have taken for the case of atom. Therefore, we will represent this in the unit, that is atomic mass unit. So we will not taking it into the gram. The unit here which is used, that is atomic mass unit, that is represented as U, that is unified mass. Let us take another example. HCl, that is hydrochloric acid. First of all, you should need to learn the formula for that also. Once you have mistaken in the formula, then the molecular mass will also get mistaken. So the formula for hydrochloric acid is HCl. Now identify whichever elements are present in this. That is, hydrogen is present, chlorine is present. So what is the mass of hydrogen? That is 1 U. Approximately that is taken as 1 U. What is the mass of chlorine? That is 35.5. Since here there is only single hydrogen, therefore we are multiplying this with 1, and since there is only one chlorine, therefore we are multiplying with 1. So multiply with 1 will give rise to the same number. So we can say that 1 plus 35.5 give rise to 36.5. So 36.5 U is the molecular mass for hydrochloric acid. It's very simple. Let us take the next example. Carbon dioxide. Carbon dioxide, the formula for carbon dioxide is CO2. The two elements present in this are carbon and oxygen. The atomic mass for carbon, that is 12, approximately 12, and the atomic mass for oxygen, that is 16. Since in this molecule there is only single carbon atom, therefore we need to multiply with 1 here, and there are 2 number of oxygen atom, therefore we need to multiply with 2. So we will make the sum, then we'll get that is equal to 44U. That means 12 plus 16 into 2, that give rise to 44. So 44U is the it's a molecular mass for carbon dioxide molecule. Next, sulfur trioxide. The formula for sulfur trioxide, SO3. So identify whichever elements are present in this, that is oxygen and sulfur is present. Atomic mass for sulfur is 32, approximately into 1, because there is single sulfur atom here, therefore into 1, that is equal to 32. Atomic mass for oxygen, that is 16, and since here there are 3 number of oxygen atom, therefore we have to multiply with 3, so that give rise to 48U. So when you make the sum of this, it will give rise to 80U. So approximately the molecular mass of sulfur trioxide is 80U. Next, ammonia. Formula for ammonia, NH3. That means there are single nitrogen atom and there are 3 hydrogen atom in this. Atomic mass for nitrogen, that is 14U. Since here there is only single nitrogen atom, you can see in the formula, therefore we are multiplying with 1, that is give rise to 14U, and hydrogen atomic mass is 1. Since there is 3 hydrogen atom, therefore multiply with 3 into, so it give rise to 3U. When we make the sum of 14U and 3U, it give rise to 17U. That is, the molecular mass of ammonia is 17U. Next example, magnesium nitrite. The formula for magnesium nitrite, that is MgNO2 whole this twice. That means NO2 is of 2 times. So let us find out whatever elements are there here. Here magnesium is present, nitrogen is present, and oxygen is also present. Atomic mass for magnesium is 24. Since here there is only single magnesium, therefore we are multiplying with 1. So give rise to 24U. Let us talk about the nitrogen here. Nitrogen, the atomic mass for nitrogen, that is 14. But in this there are 2 number of nitrogen. How? Because here bracket sign and 2 means this 2 is for both nitrogen and oxygen. So since here 1 nitrogen and this is outside the bracket 2. So that is 1 into 2, that is equal to 2. So it shows that there are 2 nitrogen atom in this. Once again I will tell you, since here the bracket sign indicates that this 2 is for both nitrogen and oxygen. And when you look at inside the bracket, there is only single nitrogen. So 1 into 2, that is equal to 2. So we can say that there are 2 nitrogen atom in this molecule. So that's why the nitrogen atomic mass is 14 into 2 number of nitrogen atom give rise to 28 U. Here oxygen is also inside the bracket. It is enclosed in the bracket and there is 2 outside. So how we find out the number of oxygen in this? 2 times, that is oxygen. 2 oxygen is there inside the bracket and into 2, that is 2 into 2 equal to 4. That means there are 4 oxygen atom in this. So we can say that atomic mass for oxygen is 16 into 4 number of oxygen atom is there, therefore equal to 64 U. So when you make the sum of these, we'll get 116 U approximately. So we can say that the molecular mass for magnesium nitrite is 116 U. Next example, that is methane. Formula for methane is CH4. This example you have to do by yourself. The atomic mass for carbon is 12 and for the atomic mass for the hydrogen is 1. So all of you find it out the molecular mass by yourself. In the textbook, example is given to calculate the relative molecular mass of water, that is H2O. Calculate the molecular mass for HNO3. So these are the 2 questions which is given in the textbook. So similarly, how I told you, you have to do in the same manner. So at that time we'll be getting the 63 U as a molecular mass for HNO3, that is a nitric acid, and 18 U as we have already discussed the example water. So we are getting 18 U a molecular mass for water. So all of you do this problem also. So it is very easy to find out the molecular mass. The thing is that first you need to learn the atomic mass and you should learn the formula properly. On the basis of formula only we are finding out the molecular mass. So that's all about the molecular mass. Thank you everyone.